Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, motion in straight line, uniform motion, position time graph for uniform motion, significance of position time graph. But before we start the topic, please watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video and share the video with your friends who may also be benefited. I will very much appreciate your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe my channel now and support. Also press the bell button and all button so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us start the class. In this video, we will discuss how to plot position time graph in uniform motion in straight line. We have to discuss position time graph of an object at rest and then pass on to position time graph of an object in motion. We will also discuss the significance of position time graph in uniform motion. For that, we will use one illustration. Let us suppose at time equal to t1, an object is at position x1. We observe the object after some time, that is at t2. Then also its position is at x1. So it has not experienced motion. It has not undergone displacement. How will we plot that graph? Along the y-axis, we take position. This is x1, x2, x3. And along the x-axis, we take time. This is time t1, this is time t2, and this is time corresponding to origin equal to t0. Here also origin corresponds to t0. So at t1, the position is at x1. At t2 also, the position is the same. So the position time graph of an object at rest will be a straight line parallel to the time axis. If we consider its initial position at t0 equal to x0, then the graph will be a straight line and it will coincide with the x-axis. That is, we will have to draw the straight line on the x-axis itself. Here, in order to understand how we plot the graph, I have taken the initial time as t1 and its position at t1 as x1. Hope you were able to follow this. Now let us pass on to how we plot the graph for object experiencing uniform motion in a straight line, that is, motion in one dimension. Suppose the object is at x0 at time t0 and it is moving with uniform velocity along the straight line with position at x1 during t1 and x3 at t2. Then the shape of the graph will be something like this. This is the y-axis, this is the x-axis, this is t1, this is t2, this point is t0. Okay. At t0, the object is at x0. T0 is initial time and x0 is initial position. At t1, the object is at x1. This is x1. Then at t2, the object is at x3. So these points are marked first and then it is connected by a straight line. The shape of the graph is a straight line at an angle to the x-axis. That is, inclined to the x-axis. Compare this with the graph that we obtained for the object at rest. You will understand it better. Now let us consider two more cases where the object is starting from points other than the origin. Let us suppose the object is not starting from the origin. Suppose it is starting from a point towards the left side of the origin. Then the graph will be like this. The graph starts from a point on the negative x-axis. You might wonder how this is possible and what it means. That is, the observer stands at the origin, but the object starts its motion from a point slightly towards the left side of the observer. On the other hand, let us suppose the object is starting from a point somewhere here towards the right hand side of the origin. Then the graph will be like this. It has to start from a point on the positive x-axis, that is towards the right hand side of the observer. So while plotting the position time graph, we have to give special attention to the time and position of the object at that time that is given in the problem. I hope it is clear. Now we will pass on to discuss the significance of plotting this position time graph. For that, I will develop this diagram like this. I have made some markings here. A dash corresponds to time t1 and B dash time t2. A2 and B2 corresponds to position of the object at t1 and t2 respectively. Let us take this angle as theta. Recall velocity. Velocity is displacement by time. What is the displacement here? OB2 minus OA2 by time. That is OB dash minus OA dash. Angle theta is subtended at point A. I will write it again for clarity. OB2 minus OA2. A2 B2, which is equal to BE divided by OB dash minus OA dash. That is this distance A dash B dash equal to AE. When we consider the triangle ABE, tan theta is equal to BE by AE. It is the slope of the graph. This is equal to velocity. So we can calculate the velocity of the moving object from the position time graph. So that is the significance or benefit or use of position time graph. In simple terms, the slope of the position time graph is equal to velocity of the moving object, and it is equal to y2 minus y1 divided by x2 minus x1. Y and x are the two components of the graph. For clarification, let me repeat, y2 minus y1 is OB2 minus OA2 and x2 minus x1 is OB dash minus OA dash. I hope it is quite clear. If you think the video was useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box. If you are watching without subscribing my channel, do subscribe it now and support. Also press the bell button and all buttons so that you get intimated as soon as new videos are posted. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.